welcome to the talk after lunch. Like Austin said, I'm Ruskin. I work at AWS. I'm a solutions architect based out of Auckland, New Zealand. And today we're going to be talking about securing cloud resources using a layered approach. The session today is extremely interactive, so we'll need your phones, scanning QR codes and things like that, and going to websites, so make sure you're ready. If you have your laptop up as well, that's fine. We want you to try things out. So the first up, I'm going to pass it over to my colleague, Ratan, who will introduce himself and start the talk off. So over to you, Ratan.
Thanks, Ruskin. Hi, everyone. Good afternoon. So my name is Ratan Kumar. I'm one of the solutions architects at AWS. Work with Ruskin, again, based out of Auckland. In terms of the agenda for the session, look, as Ruskin said, we're going to keep it interactive. We'll start with a very high-level overview of some of the security controls that you have got available in cloud, particularly in AWS, right? And how you can use them to implement a layered security around your application, or defense in depth around your application. This is, I would say, level 200 to 300 session. So we are going to start with an assumption that you have got a decent understanding of some cloud service, if not AWS, and some of the security and networking concepts. Once we have an overview of the cloud security controls, we'll jump into discussing the architecture of a demo application that we've already deployed in an AWS account. And we will then start to talk about what are the things that you can do to actually improve the security posture of this application using the layered security approach. And from there onwards, we are pretty much into the console, actually applying those controls, showing you how you can do those things. So let's get started. A little disclaimer before we get started. We are both from AWS, so we're going to use examples in our demos from AWS, showing you AWS services and talking about it. However, as much as possible, we'll talk in some of the generic terms. So even if you're not familiar with AWS, you should be able to follow along. Right, so overview of cloud security controls. So think about if we have a web application deployed right in the middle, the first layer of defense or security that you have is, of course, a strong identity and access management. So things that control who can access your application, what level of access they have got when they log into your app. Also, who can access your AWS account or Azure account or GCP account, and what level of access they have when they access those accounts to be able to administer your application. So that's the very first thing. The second is security groups, which is a stateful firewall that you have around the network interface attached to your instance. So this is where you can control which type of protocol you want to allow for around your application. As I said, it's a stateful firewall, so if you add an inbound rule, the corresponding outbound traffic is automatically allowed. So that's at the instance level. When I say instance, this is the virtual machine on which you are deploying your web server. The next layer coming from inside to out, we have got subnet. At the subnet level, you have got a bunch of controls. The first one we can talk about is network access control list, which is a stateless firewall, which means that if you're adding an inbound rule, you need to also add corresponding outbound rules. Comparing it with security group, there are a bunch of differences here. Security groups do not allow any deny rules. In case of network access control list, you can also add a deny rule. It's an ordered list, so the order in which you're going to add it, it's going to be processed in that order. Keep in mind that it affects every resource that's deployed inside the subnet. So you got to be really careful about the rules that you're adding at the subnet level. You've also got a route table, which I wouldn't say it's a security control, but kind of is in a way that it enables you to decide what happens to a network packet. Where do you want to redirect a network packet? So you can use it for things like whether you want to allow inbound connectivity into your subnet from the internet, whether you want to only allow outbound connectivity, and so on. And we'll see it as part of the demo as well in a moment. So that's at the subnet level. Then moving on to the VPC level. VPC, if you're not familiar with the concept, think of it as your virtual network in AWS. And at that level, again, there are a couple of controls that we can talk about. The first one is a Route 53 DNS firewall. So Route 53 is AWS domain name service. And one of the features that it provides you is to enable you to protect against some of those threats like DNS data exfiltration by adding DNS firewall. The other thing you have got where if you really, really want to actually inspect every traffic that is inbound or outbound within your network, you can use AWS Network Firewall, which is a fully managed network firewall. Or if you work with, on your on-premises environment, if you work with something like Palo Alto, Checkpoint, and others, they're also AWS partners, and you can deploy one of their appliances to control or inspect the traffic that is entering within your network. And finally, now right at the edge. So as you can see, we are going from inside out, right at the application or instance level. Then we go to the subnet. Then we are at the VPC. And right at the edge, we have got layer 7 firewall, web application firewall, which Ruskin is going to cover in a lot more detail. So this is where you can protect against things like SQL injection and other sort of threats. Also at the edge, we have services that protect you against DDoS. So I would say that every service that you expose to the internet, to the edge services like CDN and load balancer, it comes with some native protection baked into it for DDoS protection. But beyond that, if you have a very specific requirement, you can also sign up for AWS Shield Advanced service, where you actually get hands-on support from Amazon's DDoS response team to be helping you when you are under such a attack or something that you need to respond to. So that's a very high-level overview of the cloud security controls. So all that we have covered just now can be categorized into preventative controls because you actually allows you to prevent some of those threats or those things. Along with that, we have a bunch of detective controls also available. So logs and dashboards that is basically allowing you to actually see what's going on within your network, and then respond to it based upon that intelligence that you have got available. So look, it's just impossible to actually talk about all of that in a 50-minute session, so we're not going to do that. We are going to cover a bunch of these controls at different layers of, so we'll cover security groups, route table, Route 53 DNS, and web application firewall, as well as a bunch of detective controls that you've got available. So with that, I will now switch to discussing the architecture of the application. So we have got a very basic application deployed in an AWS account already, right? Nothing super fancy. This is a standard OWASP application deployed on an EC2 instance, which is a virtual machine on which this is running. Scan the QR code that should take you to a web page where we have a bunch of links, and we'll be asking you to kind of go to some of those links. So the first link that we would like you to access is you should see an IP address on that landing page. If you click on that, it should take you to this demo app, right? I think everyone has scanned the QR code. So look, this is, as I say, this is by default, we have deployed it in a way that there are some things that we can work on improving. Any idea, in terms of anybody from the crowd would like to mention any obvious thing that comes to your mind in terms of improving the security posture of this application? Yeah, absolutely, definitely, yeah. What else? Nice, yeah. Anything else? Yeah, so let's attempt that one, the first one, like, instance of DNS, and, there's no reason that we should be exposing the IP address of this web server to the whole internet, We don't want to do that. We want to keep the bad actors away from reaching to our instance. So how do we address that? We will address that by putting a load balancer in front of it. And why load balancer? A couple of reasons. First, from a security point of view, look, this means that we are keeping any attackers away from directly hitting our instance. Load balancer is a managed AWS service. It comes with certain features and capabilities to also enable you to add authentication and authorization. So it makes those things much more simpler. Beyond security, it also allows you to improve the resiliency of your application. So you can actually have your application deployed in a way that it's not sensitive to any outage in one of the data centers or one of the availability zones. Though rare, it's possible. So a load balancer also enables you to deploy your application in a multi-availability zone way. So with that, let me switch to the demo, and let's talk about how do we actually apply this control in an environment. So I'm right now logged into my AWS account. So if you log in, this is the first thing that you see. If you haven't already logged into AWS account before, what I'll do is I will go to my EC2 service, which is, as I mentioned, as the virtual machine on which my web server is running. I have got a bunch of instances that are already running. I can see this list. So OWASP's Day demo app is really the instance on which this web server is running. So I go there, and it gives me a bunch of details in the bottom half corner of the screen. So particularly what I'm interested in is a security tab. I go to the security tab, and I see that there is a security group information that shows me the type of protocols and the source from where those protocols are allowed. So as you can see that it is allowing HTTP, and it is allowing open to the whole world, right? So we have seen this. There are a number of different ways now to actually plug this gap. One approach could be that I actually come and just change this to, I want to only accept this connection from my IP address. So that's an option. I can do that. Obviously, it's going to break the application because others will not be able to access it. So depending on the criticality of the issue that you're dealing with, you may decide to, to approach it in different ways. So what I'll do, I don't want to break this. I'll go to my EC2 console back again, and I'll actually put a load balancer in front of it before I do anything with the security group. So I go to the load balancer, which is in the left menu. We have got option. Again, in the interest of time, I've already deployed a load balancer beforehand. What I haven't done, though, is added any listener to it. So as you can see, there's nothing listening behind my load balancer. So what I'm going to do is add a listener. And when I want to add a listener, it is asking me what I want to do. I want to forward the traffic, all HTTP traffic coming on port 80. I want to forward it to where? To a target group in which all my web server instances are already listed. So I select that. Here you've got other controls like whether you want to route traffic, certain percentage of traffic to this target group or others. So I will add this listener. Once the listener is ready, attached to my load balancer, now I should be able to actually go to my EC2 instance security group and update the security group in a way that I only want to accept the connectivity from load balancer and nowhere else. And how do I do that? I do that by actually checking the security group in which this load balancer is associated with. So I've got, so this load balancer has got a security group assigned to it. Now, knowing that, I'll go back to my instances list. I select my instance, go to the security, go to security group, edit the inbound rule, and I'll delete this. I'll add another one, HTTP. And now, instead of providing a source CIDR range, I'll provide a security group. What that means that anything that is part of this security group has got automatic access to my application, and only they can access this application, and nothing else. So I save this rule. And now if you go back to that IP address and try to access this application, you shouldn't be able to do that. So if I go and do this, it's not working. However, if I go back to my landing page and try to access the link through the DNS name of my load balancer, I'm able to access it. So that just shows you the feature that, or the capability that security groups provides you, and how you can use that to protect your application by putting a load balancer in front of it. Now, moving on to the next thing. So this is what we have got right now. We have got two subnets in which two resources are deployed for me, an instance on which the application is deployed, and I've put a load balancer in front of it. As you can see, both of them are running in public subnet. What do I mean by that? So I mean that, as you can see, both of them have got a route table attached to it that allows them to, accept requests from the internet or send requests to internet, which is fine for the load balancer subnet, the subnet in which load balancer is running. But I don't want to have that set up for the subnet in which my web server is running. And why? Because look, hey, what if accidentally somebody goes to that security group, which I have just fixed, and then adds that rule back again, either maliciously or accidentally. And to protect against that, what I'll do is I will update the route table of the subnet in which my web server instance is deployed, and make sure that it only can send outbound requests to the internet, but not accept anything coming from the internet. And why I want to do that? Because let's say if my web server wants to download any security patch or any upgrades, it still has got access to internet via an NAT gateway, but I cannot don't want anything reaching to my instance directly, even if somebody accidentally updates the security group, right? So again, back into the console, let's have a look at how do we update the route table to add another layer of security in front of it. So going back into my instance again. So this time, instead of going to security tab, I'm going to networking tab, okay? And on the networking tab, it shows me the subnet in which this application is deployed. So I go to the subnet, select the subnet, go to the route table that's attached to this subnet. As you can see that it's showing me that it has a default route pointing to internet gateway. So I select that route table because I want to update that. And now I want to edit this, and instead of pointing it to the internet gateway, I'll point it to NAT gateway. So as I said that this instance can still initiate an outbound connectivity to internet, but cannot have anything reaching directly to it. So I updated the route table. Now, just to be absolutely sure about the concept that I mentioned, let's say if I go back to my instance and say just for the testing purpose, I want to go back and update the inbound rule, and again allow HTTP from everywhere, And let's see if that works for this application. So you can see that security group, which is attached to the instance, is allowing HTTP from everywhere. But now, because there is no route attached for accepting connectivity from the internet, there's no way to reach to this instance. Yeah. So that's at a subnet level. Now moving back again, we are moving to the VPC layer now. So one of the controls that I want to talk about is how can you use Route 53 or DNS firewall to stop against a DNS data exfiltration sort of a scenario. So this is where we are right now. We have got two subnets, a public subnet and a private subnet, an application load balancer deployed in the public subnet, and my instance is running inside a private subnet with only outbound connectivity to internet. So now I want to put a DNS firewall to protect against anybody shipping sensitive data from my environment, from my network. Say if there is any spyware or something that gets installed on my web server instance, I want to make sure that first I know about it, that what are the DNS names that they are actually querying, and then plug that gap. So I'll jump again into the console and talk about DNS firewall. So the first thing I want to talk about is how do you enable query logging? So I want to make sure that every DNS query that is originating out of my VPC or out of my virtual private network is logged. So the feature that Route 53 provides you is one of the capabilities is query logging, and what I've done is that I've associated my VPC to it. So you can see that I go to query logging, and I can see that my VPC is already associated to it, what means that every DNS query is going to be logged inside a logging service that we have called CloudWatch. So if I go to this destination ARN, which is the ARN for my CloudWatch service, I can see that there are log streams here, and if I select one of them, it should show me all the DNS queries that are originating from my from within my network. So as you can see that the query name is this, it's coming from the source address is this, and a bunch of that. So there's a lot of log that it's collecting. It's in the JSON format, and it's hard to actually read the logs, in this format. And say if I want to actually process this log and query it in a easy to use manner, one of the capabilities that you have got available in CloudWatch is called Logs Insight. So I go to that feature, and in this, I've already saved a query that because I want to list down all the domain names and the number of times that they have been called. So I've got a query here. As you can see, I'm just doing a count star of all the the number of times that a query name has been called. I'm also interested in the source address, and I want to just get the top 10 of it. I need to select my log group, so I select that, and then I query this. So it's getting some data, and as you can see that it gives me a top 10 list of all the domain names that my applications running inside my VPC are actually calling, and things look good, except that I can see that there is this bad.sademos.net. I've deliberately injected that, by the way, so there is something to demo. How about I want to block that? I want that the domain resolution for that should fail. And for that, I go back to my Route 53 dashboard, and as you can see that there is a DNS firewall option here. So I'll go to rule groups. So I'll select this is the firewall, and again, to save time, I've associated my VPC to it, but as you can see that there is no rule at the moment. So the firewall is attached to my VPC, though there is no rule. So I'll just go add a simple rule. I say that I want to block domains, and I've got a bunch of options here. I can either pick a list of domains that AWS has curated based upon the threat intelligence that we have, at global level, or I can create my own list here. So as you can see that there are a bunch of domain lists that I've already pre-created, or I can create a brand new one here. Suspicious domains or something, and I'll just copy paste this. Where is that domain name gone? Here it is. Let's come here, paste, and Now you've got an option whether you want to allow that domain name. Are you creating an allow list or a block list? So in this case, I want to block that domain, and I add that rule. So yeah, that's really how you first find out that what are the domain names that your applications are actually making calls to, and then use CloudWatch Insights to gather information about suspicious domains, and then use that information to go back into DNS firewall to actually put firewall rules accordingly. With that, I will actually pass it on to Ruskin.
Great, thanks, Ratan.
Okay.
Can everyone hear me? Cool. All right, let me just get the Wi-Fi sorted, and then I'll be away.
You'll be pleasantly surprised by the number of things.
So while that's happening, what I want you to do is just scan that QR code and go to it. So that's not the OWASP website, but it's got a whole bunch of links which I would like you to click on in the next 15 to 20 minutes. So just go to the website, keep it available on your browser. Yep. Swap display, is that a bit better? Great, so Ratan mentioned how you secure your VPC, your security groups, and your NACLs. What we're going to be doing is continue on that journey outwards, right? So we secured our network. How do we continue securing it at the edge as well? So I'm going to demonstrate a lot of these managed services which you can use. And it's not just in AWS, right? It's in GCP as well, Azure as well. So there's high recommendation to use managed services as much as possible, so you don't have to do any of the lifting or heavy lifting yourselves. So let's have a look at that. So hopefully all of you have been to that QR code and you have that web page up and running. And let's just do a quick recap. So you are a user. You are going to the ALB through the instance, right? So that's what we demonstrated so far. What I'm going to demonstrate today a little bit is also putting a CloudFront distribution on front. So this is essentially a content delivery network which lives on the edge of the AWS backbone, right? So it's essentially protecting your resources so your attacks and traffic doesn't even get to your load balancer if need be. So let's have a look at that. So on a lot of times, and as shown before as well, you can access the load balancer directly, and that's okay. But often customers or users don't want to do that. Anyone know what are some of the reasons why you might not want to expose your load balancer directly? It's a valid approach, but why would you not want to? Anyone want to hazard a guess? DDoS. Yep, DDoS is good, but the load balancer is protected from DDoS as well, just FYI, but that's good. What about the DDoS attack on the load balancer is important? Have a look at the boundaries which I've got and see where the CloudFront distribution is and see where the load balancer is. What does that tell you? That the load balancer is within your VPC boundary. So the traffic is hitting it, it's just protected. So the traffic is still getting there. But with things like a content delivery network and putting a measured DDoS perimeter around the edge, your traffic doesn't even get to the ALB. So that is what we will be demonstrating through the next 10, 15 minutes. So let's have a look at the demo for the load balancer. All right, so everyone can, I'll have to escape the screen. Everyone can get to this page on their web browser. So let's browse to the app. Cool, so this is the app as we've shown it, right? And as you can see in the URL on top, I can zoom it in a little bit. Nope, it just zooms in my page. It is actually going to the load balancer on top. And if you can see, there's a little lock there, and it's got a cross on it. Anyone know what that means? Sorry? It's what? I can't hear you. Not secure, exactly right. So it is going to HTTP only, right? So the load balancer is exposing an HTTP listener. So that's okay, but not in the modern world, right? So HTTP is not really secure, so we want to secure it. That's the first thing we want to do. So how would we go about doing it? So let's have a look. So let me go back to the front page of my AWS account. Zoom it in a little bit more. So as we go into the front page, the load balancer is located in the EC2 console. And again, the same thing applies for other cloud providers as well, right? So as the load balancer is, and as Ratan showed you as well, it has a listener, and it has a HTTP listener. So let's have a look at that. Right, so we were hitting the HTTP listener. We also have a HTTPS listener, and you can actually hit that as well. So let's try that. So if you have that page open, try the HTTPS one. Okay, so wait a minute. It is secure, but what's going on here? Why is the browser warning us of a potential risk? And the certificate is there, close. It is signed by the CA as well, but okay. So, but the URL we are hitting is not the same as what's specified in the certificate, right? So even though you're using HTTPS, it looks like a dodgy certificate because the URL you're hitting is not quite matching the certificate here. Let's go to this URL anyway. Go to advanced, accept the risk and continue. So yep, it is HTTPS URL, but you still have that little lock on top, and it's got a little exclamation top. So it's secure, but not quite secure. It's a little dodgy security there. So what we can do in a application load balancer is essentially put a Route 53 DNS record in front. So I've already done that for you, right? And what that allows us to do is match the certificate record which we have used. So let's try that one more time. So now if you're on the ARB, which is extremely small, apologies, let me zoom in a little bit more. So you see the URL of the application load balancer, and see how it's different from the friendly load balancer one, right? So let's try and hit that one. What I'm going to do is open it in a private window, actually. And here we go. So it's got a nice, no warning again. The locker is nice and secure, no exclamation mark, but it's automatically gone to the HTTPS one. So if you want to try this out on your local browser or your local phone, there is a setting which you can disable to make sure you can go to the HTTP only website, not the HTTPS. So if you want to really try out and test it out on your own browser, go for it. But right now, all that's happening is we have two URLs exposed. One is a non-secure one on HTTP, and the other one is a secure one on HTTPS. And you can go to both of these, right, as it stands. With the application load balancer, you can do this thing called a redirect. So what we want to do is force everyone to use the secure HTTPS endpoint. So I'll demonstrate that quickly and see how we can do that. So we go to the HTTP endpoint over here, and we click on rules. So essentially it says if anything comes along, just forward it to a target group. So Ratan did demonstrate what a target group is. It essentially has a bunch of EC2 instances or virtual machines in there. And currently, if there's anything which goes to that listener, push it off to the web server. But we want to change this. What we want to do is, if anything goes to this listener, we want to redirect it to the HTTPS listener. So let's delete this one and add a redirect. So HTTPS, cool, port 443, original. Awesome, updated. So now let me close these off so we have nice and clean browsers. Now let me go to the HTTP one. And it will go to HTTPS very quickly. So you don't really see the redirect in the background. But what we can do is demonstrate that through a terminal window. So let me grab that for you. Right at the top. Cool. Can everyone see that text there, or is it too small? Let me zoom in a little bit more. There we go. Cool. So if I go to the HTTPS one, it gives me a nice 200 there. But if I go to the HTTP endpoint, hopefully it should give me a redirect. Cool. So there you go. So it is actually giving me a 301 moved permanently. It actually goes to the HTTPS endpoint. So we haven't changed the code. We haven't changed any of the background application logic, no deployment changes. We have used managed services at the application load balancer to essentially do a redirect from one point to the other, right? If you have any questions, feel free to ask me, or I can just carry on. We'll have some time near the end to ask some questions as well. Great. So now we've got application load balancer working. We've got a redirect going. Awesome. So what I'm going to demonstrate now is how do we protect this further? All right, so this is where the web application firewall comes in. So as you can see right now, the users are directly going to the application load balancer. But we have no real protection on it, right? So anyone from anywhere can go to the load balancer. To demonstrate that point further, what I'm going to do is I have 3 virtual machines deployed across Sydney, India, and Ohio. Orange block is the application we are running, which is in Oregon, right? US West. The green dot in New Zealand is essentially us testing this application out, right? So next step I'm going to do is I'm actually going to block the Mumbai region, or the users in India, and block the users in Sydney. But what I'm going to do is do it the other way around. So because I don't know all the threat vectors out there, I'm going to make it easier for myself and only allow people I want them to use the applications. For example, people in New Zealand, which is essentially the IP address of my mobile hotspot, and the IP address of the people in Ohio. So let me show you how you do that. So let's go back all the way to the AWS console homepage, right? And there is a service called WAF and Shield. So this is, again, a managed service for you, right? So you're not setting up any IF config rules on your host or anything else like that. You are doing it using a managed service called Web Application Firewall. And it has this thing called a Web Application Control List, right? Or an Access Control List, or an ACL. So similar to what Ratan showed you for networks, NACL, which was a Network Access Control List. WAFs have this concept of a WACL, which is a Web Access Control List. So let me go to the correct region, which is in Oregon, which is where my load balancer is. I have set up a WACL already to save time. And let's go to the rules. And it's got an allowed IP rule here. Let's dive a little bit deeper into it. So essentially saying if there are connections from these 2 IP addresses, 49.224 is essentially my mobile hotspot here, and 13.59 is the US EC2 instance of the virtual machine. Currently, it's just 1, but you can change this to have a range of side ranges if you really choose to. All right. And the reason currently it was allowing everyone to go to it is if you go back to your rules, have a look at the default action over there. So the default action, if it doesn't match any rules, is allow. All I have to do is change that from allow to a block. Let's see how that works. Actually, to demonstrate that before, I'm going to do a quick. So I'm going to log into my Mumbai region, which is that. I'm going to log into my Ohio region, which is that. And I'm going to log into my Sydney region, which is that. Cool, so 3 virtual machines in three different regions, just to demonstrate the point. And let me do the curl bit again. So this was the curl. All right. Curl here, curl here, curl here. All right, so you're seeing 200s everywhere? Awesome. Now let me go back to my web application firewall and simply change this to block. Cool. It takes a few seconds, minutes to apply that in a distributed way across all the different ways we're doing it and across all the different constructs we have. So let's go and try this out again. Let me just clear the screen. Cool, let's do this over here. Cool, you get a 403. You get a allowed. And we should get a 403 there as well. So Mumbai is blocked and Sydney is blocked, as you can see it. What's allowed is Ohio. So that is essentially saying that we only want to allow connections to our load balancer from this IP address. Perfect. So now you have all these security setups and all these perimeter controls all set up correctly. How would you go about measuring and looking at if it's actually working? So you've got preventative controls. How would you go about doing detective controls, right? So to do that, we have a service which allows you to query logs. So to do that, I've set up logging on the application load balancer. So let's have a look at that. And just to sum up the WAF as well, we've got IP-based protection. Like I told you, it's only on IP-based, so you might want to add every IP address, but you might not want to do that. You might want to do a geographic-based protection, so you can also do that using geographic. And all we did was change the default action to block. So that was all we did. So as you start looking at these logs and try and do it in a way to how would you actually prove that it's actually working? So we have a service called Athena, which allows you to query these logs. So let's quickly have a look at that. So all these access, all the various IP addresses which are hitting your load balancer can be logged somewhere, right? We wouldn't recommend you trawling through these logs manually. I mean, you could if you're doing it in the dev environment, but imagine a test environment or a production environment. There's no way you're going to trawl through all of these logs in one of those big environments, right? So you would do it using a tool called Athena, for example. So over here, it essentially says you can write SQL-like queries in a tool, and it say you can get it from ALB logs, which is where the logs are stored, and you can query between a particular date range, right? So what I've done is I've pushed some traffic in the past couple of hours through my load balancer to give you this. Otherwise, it takes a wee while to generate traffic. So let's run this. And on the bottom, it essentially gives you how many gets and posts, etc., are coming through, and which IP addresses are coming through. You can do a group by, etc. So quite powerful. Again, great, but you can go one step further. What I've also done is created a dashboard. So I've used this tool called logs.io, which is an AWS partner as well, and there are lots of other partners out there, either with Azure or Google Cloud, which you can use as well. But this is essentially a visual way of representing how you're getting hit, how your application load balancer is getting hit, right? So here we have we have a graph showing you where what the status codes are. So let me just quickly refresh this. Yep, gives you a little bit of a better range. So you got some 200s there, which is our success runs. It tells you the difference between gets and sent bytes received and sent. And on the bottom, it's got a nice little geographic view of how many requests are coming through. So obviously, I'm doing a lot of queries from New Zealand. But if I go back in history a little bit more to maybe 2 hours, so let me do 3 hours ago maybe, it will show you a slightly different view. Maybe even more. Cool, there you go. So you see a little bit more activity in the US regions as well and the Mumbai region. So if I go a little bit 3 hours ago. So that was when I was doing my testing to generate that data. Awesome. So we've got we've got application load balancer sorted, and we've got web application firewall sorted as well. So let's quickly have a look at CloudFront in the next 2-3 minutes. So we have the web application firewall pointing to the load balancer, but now what we want to do is do it via CloudFront. So we don't want users to go directly to the application load balancer. We want them to go through an edge cloud delivery network, which is a CloudFront. And you can also put your web application firewall from the application load balancer to the CloudFront as well, right? So all your protection is on the edge perimeter. So nothing is hitting your VPC or inside your network there. So let's have a quick look at how we go about doing that. So for the purpose of this demo, I've actually set up a CloudFront distribution already. Cool. And if you go to this web page, you will see the CloudFront URL as well. So let's navigate to that. So it's giving me a 403 forbidden here. Anyone know why it's doing that? So just think of the demo flow we have so far. So for the interest of time, I'll tell you. We put a web application firewall on the application load balancer to block any IP addresses other than the 2 IP addresses I showed you. CloudFront comes from its own set of IP addresses, which we don't really care about. So the first thing we need to do is disable the web application firewall on the application load balancer. So let's do that quickly. So what I'll do is I'll go to the WAF and Shield console, and I'll simply remove the load balancer from the list of web ACLs there. Go to Oregon. That's where my web VACL is. Cool. And just disassociate my application load balancer from it. There we go. Disassociate and go remove. Easy as that. Cool. And now if I refresh this, voila. So now I'm going to my application using CloudFront, which is the edge service. So essentially, all I showed you with the web application firewall, etc., can be applied to CloudFront as well. So essentially, all I would do is say, this is my web application firewall for CloudFront, just associated that, exact same process. But now I'm actually going to the edge, and my edge is protected. So traffic doesn't actually land in my application load balancer. There is one extra step you need to do, which is essentially make sure and test that your traffic is coming from CloudFront. But given that we're running out of time, I think I'm going to skip that step and go right to the conclusion. Great, so quite a lot of content to cover, quite a lot of information. Hopefully you got the gist of how do we move from a layered security group to NACLs, all the way to the edge, to the application load balancer, to CloudFront, to using web application firewalls, and we protect at all layers. Consider all threat vectors, right? So it's not just about 1 or 2 users coming from different IP addresses, but think from a global scale, right? Your DDoS needs to be protected from everything, everywhere. Don't underestimate the footprint these days. The next one is we want to do it in layers, right? So not just one thing, but we want to protect that one thing, second, all the way up the chain. We want to trust but verify. So we want to trust our controls, but also verify them using dashboards, logging, etc. we want to automate. So everything I showed you here can be automated using things like the command line interface or infrastructure as code as well, and that can be applied to any cloud provider these days. Finally, dashboards are great, but you're not going to sit in front of the dashboard all day looking at pretty graphs, right? So set up alerting, right? If you're looking at different IP addresses which are hitting your web server or your app, a lot of times in the last hour or so, set up an alert. You're not going to be looking at a dashboard all day. So with that, I'm going to open it up to any questions. But if you don't have questions, we also have a feedback link as well. So if you can go to that link and give us any feedback you can, positive, negative, we always appreciate it. We try and make ourselves better, present some relevant content. But do we have some time? It's actually 2:20 now.
We have time for 1 or 2 questions.
Okay, there we go. Sure.
So, if EC2 has an external DNS server configured, the Route 53 has capability to intercept and apply DNS-based firewall.
I'll let you
Yeah, if the EC2 is the mic on. If the EC2 is part of the VPC in which we have applied the DNS firewall, yes, it will be intercepted.
Even though it does not go to AWS DNS server, even if it's an external, it has the capability to intercept and block it.
Yeah, because all DNS resolution happens through Route 53 DNS that runs at the VPC IP address +2. So that's where the DNS resolver sits, and everything goes through that. So once you put Route 53 firewall, it intercepts that, then it blocks it.
No, the question is like external DNS server, something like
We don't have time for that many questions, I'm afraid.
We can sit outside, yeah.
Yeah.
We can,
Catch up outside.
yeah.
Thank you very much.